Hey everyone, let's just jump right into it. You literally can't buy a toaster these days without someone slapping an AI sticker on the box. Artificial intelligence, machine learning, they're everywhere. But here's the thing that trips so many of us up. Are they actually the exact same thing? I mean, if machine learning is what we use to build all these AI systems, why even call it machine learning in the first place? And honestly, what is a machine actually learning anyway? Today, we're going to clear up that universal confusion and finally nail down the exact difference between these two massive buzzwords. So here's our game plan. We're going to start by looking at the classic programming problem. Then we'll see how machine learning swoops in to solve it, map out the entire AI hierarchy, talk about the big data catch, and wrap up with the professional mindset you actually need to use this stuff in the real world. Let's get to it. Starting off with part one, the programming problem. Because, to really understand why machine learning was even invented, we first have to look back at what computers have been doing for decades. Historically, computers have been absolutely incredible at following strict human-written rules. Think about a standard billing system, right? You take a pricing rule, apply it to the usage data, do a little math, and boom, you've got a bill. Flawless. But that only works as long as we humans actually know all the rules. And out in the real world, things just aren't that simple. Take predicting the price of a house, for example. The final price relies on this massive, tangled web of variables. You've got location, the square footage, the overall condition, market trends. Heck, maybe even the neighbor's obnoxious dog plays a part. So ask yourself, could you seriously sit down and write a strict mathematical rule for every single possible combination of those variables? No way. It's completely impossible. And the bigger issue, we probably don't even know all the rules ourselves. Like, we intuitively know these factors matter, but writing down exactly how they interact mathematically, it's just too complex. We can't anticipate every single rule, which means we needed a massive paradigm shift in how we approach computing. Which brings us to part two. Enter machine learning. This is where we completely flip the script. Just look at the contrast here. In traditional programming, humans write the rules, we combine them with data, and the computer spits out an output. But with machine learning, we flip that equation entirely. We feed the system massive amounts of data and past examples, like, say, thousands of historical house sales, and the system actually outputs its own predictive model. It's wild. Instead of a human agonizing over writing every single rule, the system is digging through the data and finding those hidden patterns all on its own. It's learning from the past to make highly accurate predictions about the future. And the craziest part is, you're already relying on this process every single day, probably without even realizing it. When a streaming app recommends your next binge watch, it's analyzing your past viewing patterns. When your bank suddenly blocks a weird charge, that's a system spotting fraud based on transaction patterns. Navigation apps predicting traffic, businesses forecasting sales, the speech-to-text on your phone, they are wildly different applications, but they all share that exact same underlying philosophy. Learn from the data and apply those patterns to something new. All right, moving on to part three, the AI hierarchy. Now that we've got a handle on how a machine actually learns, let's zoom out and see where this fits into the bigger picture. Let's start at the very top. Artificial intelligence is essentially a broad, overarching field of technology. It's focused on creating systems that can perform tasks that usually require intelligent behavior. So AI is not just one single piece of magic tech. It's a massive umbrella. It covers systems that can understand human language, recognize images, find patterns, make predictions, solve complex problems, you name it. AI is the whole shebang. It really helps to think of this like a set of Russian nesting dolls. AI is the biggest doll, the broadest field. You open it up, and nested directly inside is machine learning, which is that major approach we just talked about that learns useful patterns from data. And if you open the machine learning doll, nested right inside that one is a term you'll hear thrown around a lot: deep learning. Deep learning is basically just a highly specific flavor of machine learning that uses complex, multi-layer neural networks. So to recap, AI on the outside, machine learning inside that, and deep learning right at the core. Okay, part four, the data catch. It is definitely time to ground some of this massive hype, because as powerful as this technology is, it's absolutely not magic. The absolute truth here is the oldest rule in computing: garbage in, garbage out. The quality of your results literally depends entirely on the data you feed the system. Imagine training an AI on data that's inaccurate, incomplete, or totally outdated. The system is still going to confidently learn patterns, but those patterns are going to fail spectacularly out in the real world. Just because an AI gives you an answer doesn't mean it's the correct answer. It's just outputting what it learned. If it learned from bad data, it's going to be totally wrong. So please remember this golden rule. More data does not automatically mean better AI. This is such a crucial lesson. Amateurs will always ask, hey, how much data do we have? But true professionals ask, do we have the right data for this specific problem? You can't just hoard a mountain of garbage data and expect a genius system to pop out. Your data has to be useful, it has to be reliable, and most importantly, it has to be highly relevant to whatever you're actually trying to solve. Which brings us perfectly to our final section, the professional mindset. Knowing all these definitions is great, but let's say a coworker comes up to you tomorrow and says, hey, let's use machine learning to solve this new problem. Do you just immediately start building a model? Definitely not. A true professional workflow always starts with one thing, the problem itself. Ask what exactly you are trying to achieve first. Then look at your data. Is it actually reliable? Only after that do you even think about the solution. Is machine learning actually the right fit here? And finally, you test and verify. How accurate does it really need to be? What happens if the system messes up? You have to verify it actually works out there in the wild. Because here is the core insight of this whole explainer. Machine learning is not always the best answer. Seriously, a simpler, traditional, rule-based program is almost always easier to understand, easier to maintain, a lot easier to test, and way less expensive. Don't overcomplicate things just so you can use a fancy buzzword. If simple rules get the job done accurately, stick with the simple rules. So I want to leave you with this provocative thought as we wrap things up today. Are you using the most advanced technology, or are you using the right technology for the problem? Because the ultimate goal isn't to just shove AI into everything because it sounds cool. The goal is to solve real-world problems correctly, reliably, and efficiently. Keep that front of mind. And that covers the vital differences between AI and machine learning. Next time on this explainer, we're taking the next big step. We are going to detail exactly how a machine actually learns from all that data by diving into the 3 fundamental approaches: supervised learning, unsupervised learning, and reinforcement learning. It's going to be a great one. You won't want to miss it. Thanks so much for hanging out with me today, and I'll catch